Welcome back to the Gabster channel. Today we're going to talk about measuring the ripple on your power supply down to 1 microvolt. Yes, you heard me, 1 microvolt. That's going to be very low measurement. What you're going to need is something very simple. There's no fancy equipment needed here. All you're going to need is a computer that can run on its own battery. A sound card. This is a Focusrite, and you can get them new for 150 bucks or used for like 100 bucks. And a nice cookie jar. You can get those anywhere from any store. You will also need a couple simple components. I'll go through those in a minute. I'm gonna put a link below about the sound card if anybody interested in this particular one. It's pretty good, and it has a really low noise, and that's critical to this particular application. For those of you who don't know what ripple is, let's say you have a power supply, so you're converting AC to DC. So the DC current that's coming out, as good as it is, there's always a small amount of AC still left on it. And that's what we call a ripple. Some of the inexpensive power supplies will have ripple in hundreds of millivolts, and some of the extremely really good power supplies will go down to microvolts. And these are extremely rare, but they're out there and you can find them and build them yourself. So if you ever worked with the oscilloscope, let's say here, as good as they are, they cannot measure down for more than 10 millivolt, 2 millivolts, but that's about it. Because you start having noise coming from the environment, they create their own noise as well, so they cannot go there. The other option is to go and buy yourself some very fancy equipment into the thousands of dollars, and now you're into big money. But for us, for a hobby, saying if you don't want to go there, we want to do it simply with just using a couple $100 worth of stuff, and we can get there. So to measure anything in the microvolt level, we need to amplify that level. So we're going to use a sound card, and that's going to amplify that ripple, because ripple is just like music. It's basically an AC signal. And then we're going to use the computer with a software that's free, and it's called RU. And you're going to need a laptop that could run on battery. So this way you can avoid any noise. And also the sound card is going to be connected to that laptop, and that's also going to run on its own batteries, and then it will be also very low noise. To protect the sound card, we're going to use a box, a metal box, has to make sure it's metal. So the blue here is what represents the box. And then, so this is the input. So the positive part is going to go into a fuse, a very small fuse, 250 milliamps, or even lower you can if you like. A capacitor. This is going to be a 600 volt capacitor, about half a microfarad. And a couple diodes, like just a regular inexpensive 4007s. And we're going to have an output, it's going to be an XLR, because our sound card have an XLR input. So how does this schematic works? Is what happens is you have DC coming in here, so the capacitor is going to get rid of all the DC, and all what's going to go through is a ripple, which is AC. So that's going to go in here. We're only measuring very low voltage here, so we want to make sure we don't get anything high voltage into our sound card. So we're going to put a couple diodes and opposing each other. So only up to 0.5 volt will be able to go through. Anything above half a volt will short here. And if it shorts really bad, you get the fuse here as a protection as well. And the output's going to go into the XLR, so 2 and 3. And one which is ground is going to be attached to the case as well. And so is the BNC ground is also attached to the case. And it's very important that your case is grounded. So you need to run a wire and ground your case, because say you're measuring some high voltage stuff and you accidentally reverse the polarity, now suddenly you have 400 volts sitting on your case. You touch that case and you could die. So you need to ground your case as well. So it's a very simple circuit. So, and the reason we want to put it in a metal box, because everything needs to be shielded. Remember, we're measuring microvolts here. So anything, like sometimes you wave your hand, you do touch something and you could introduce a lot of noise. So shielding is of extreme importance. So I've got this circuit, instead of being in a small box like this, I personally have it in a part of a big testing box that I've designed before, and one day I'll go through that. That'll be a separate video. But the part of it that's high voltage here, or for ripple, it goes into, this is the BNC input here, and this is the XLR output here. And the XLRC output here goes into the input of the sound card in here. And the very important part, I cannot stress that enough, is to ground your box. So this is the ground. There's a couple grounds here, but this one is connected to my power supply, basically over there. And it's got a ground terminal right here. So that's grounded. And from the main ground post here, I can get another lead of ground like I have here. And if I'm testing something in a tin box, I can put it like this, close that on it, and now your whole tin can is also grounded. Because if you follow all these safe, like keep everything safe and also keep everything away from any, shielded from any external interferences, this is how you're going to get to the low microvolt level. So that was the hardware part. Now let's look at the software part. For that, you're going to need a software called RU, and you can get it, download it from the internet for free. You're welcome to support them if you find it helpful, but you don't have to if you don't want to. So we're going to open up RU. So here it is. So I launched RU. I am running version 5.2. So you're going to see a preference wrench here, so you click on that. What you want to do is, in case this is not 96, make sure you select 96 kilohertz sample rate. The output device, you want to select the Focusrite, because that's what the audio, the sound card that we have. Make sure, in my case, I'm using all left channels, so because I have two microphone inputs and two outputs, so I'm going to use both left if it's selected right, so make sure you change it to left, unless you want to use the right channel, it's up to you. But stick to one channel all around. And for the input, so instead of default, you're going to again select your Focusrite or your sound card. And again, it's going to be on the left channel, and that's going to be all left channel. Everything is on left. So that's pretty much for this part. And then what you want to do, you want to basically calibrate the sound card. Before you're calibrating, you click calibrate, you need to run a cable from the output to the input. And let's show you how to do that. So to calibrate the sound card, you're going to need a cable. On one end, it needs to be an XLR. Basically, it's a male XLR. On the other end, it's a TRS. So the XLR is going to go in here, like that. And the TRS will go on the back. There's a line output, and that goes in here. It's a bit of a pain in the butt. I wish they were both XLR, but they are not in this unit. So, but you can get those cable easily. I'll put a link on Amazon where you can get a cable like that. So basically, you're looping from input to output, and then we're going to run a calibrating test. So once you loop the cable on the sound card, we're going to run a calibrate sound. So we're going to click calibrate sound, and it tells you to connect the input to the output like we just did. Click next, and then click next, and then it tells you to adjust the sound level. So you increase the sound on your volume on the Focusrite till it gets as a little bit higher here. So here we go. And then you click next, and then next again. And the software will go through a whole set of things. Just let it do its thing. And then when it's done, then you could click on make calibration file. You give it a name here, say OK, give it a name again. In my case, I've already made one. So Once you make it and save it, you can always go back and find it. So mine is here, and so it's called focus calibration. So I can always, you only have to do this once, you don't have to keep doing this. So once you make that file, you can always bring it back. And that's pretty much it for this part of the software. Next, we're going to go into and click on RTA here. And that's going to bring us the kind of like the FFT portion here. And you want to click on the record button right there. And so we're going to click record. And you're going to get this, you can see the noise that's happening now. Where you see that little icon here, you're going to click on it. And usually it's default to dBFS. What you want to do is click volt. And that's going to give you the voltage. If you don't see all these, you could be running an old version. Make sure I'm running here on 5.2. So make sure you're running 5.2 above, otherwise you can get some things that are not available for there. Now the noise level here is quite high. We're about 10 millivolts, which is not the greatest thing. So the reason is this computer is running on the grid. It's not a laptop, and so we're going to switch to the laptop and show you how we can get that voltage lower. We also going to need to calibrate the noise level. So let's do that calibration. So from here on, all you need to do, we don't need to have the loop cable anymore, so we just have the input going into the XLR here. So you put that in here. On the other side, this is a regular XLR, this time cable. It's got both XLRs. On the other side, it's going to go into that box. Just remember, if you didn't build a big box like mine, it could be just your input could be just on a small box, just like here, but mine is in a bigger box. That's the only difference here, but doesn't make any real difference. So this is coming from the output of your box. So this is basically the XLR here. Now our input becomes, you remember we made a little BNC here, so that's our input here. The input goes into, so it goes from the BNC cable here into our tin can where we're testing stuff. So it's going to go in here, and this is where we can put our power supply, for example, here that I'm testing right here, for example, or any power supply that you could be testing. But before we test anything, we want to see what is the noise level of just this setup alone. Just a cable, nothing running in it. So we're just going to close the box here, and because we're not going to be able to measure any noise low if we already have too much noise to begin with. So by keeping everything shielded, we're hopefully going to keep our noise super low, and you'll see how. So back to the software here, we're going to go on my Mac little portable computer, and we're going to basically exit from the preferences. Remember, we already put our sound cards here. So this is on a Mac, same idea, 96 kilohertz. We got our Scarlett here. It should be at 32 and 32 here. And everything is on the left channel. So we're going to put everything on the left channel. And we've got our calibration file. It's already in here, already put it in. If you're not, you could browse and you find your calibration file. And then you can exit from here. And now we're going to go on what we call here the RTA section. This is like basically, it's going to show you, it's like an FFT. So it's going to show you the noise. And we're going to just make the screen a bit bigger. And here we go. Now, if you press record here, we're going to see the noise level. And as you can see, I've got about 50 microvolts here. But one thing, just when you go into the first time here, usually this defaults to dBFS. If it is, just click on that little arrow and select volt. We want to go into volt here. And now the reason the noise is higher, because this computer is still running on plugged into the power. If I unplug it, this is from here, notice how the sound is going to get much lower. We are down to half a microvolt sound noise. So very safely up to 1 microvolt. So now we can basically test equipment up to like half a microvolt of sensitivity. I mean, this not this is not a $27,000 equipment piece, but still, for a couple $100 here, $100, we are able to do some tests that requires some serious money otherwise to test those. There's one little thing is we don't know if these measurements are correct. So let's plug it back into the power here for a second. How do we know that if it's telling us 100 microvolt here, that it is actually 100 microvolt? So we need to calibrate that. So there is a calibrate level here, and what you do, you can click calibrate here. And what you're going to do now, actually before we click calibrate, let's just close that for a second. We need to send a signal to our sound card that about, let's say, pick a number. Let's say we're going to send it a signal of 1 volt. And on 1 kilohertz. 1 kilohertz usually is like an average frequency we like to test things with. So we'll send it a signal 1 kilohertz of 1 volt. So there's a couple ways here you can do that. You could either, if you have a signal generator, for example, I have one sitting right here. So I could use that signal generator. If you don't have one, do not panic. There is a cheaper way to do it. Well, you can buy a signal generator for like I think like about $80, $100. I'll put a link as well for that. If not, the other way to do it is you could just use your phone and go on the net. You can download a sound that's 1 kilohertz, and with your voltmeter you can test the output of the sound to be 1 volt, and that's a cheap way to do it. But we do have here a signal generator. We're just going to tell it it's defaulting to 4 volt. We're going to go to 1 volt, and it's a 1 kilohertz wave. So next we're going to open our tin box here, and so this is the cable that's coming from the BNC. So basically, this is remember, if we go into our schematics, this is the input. Where are we here? So this is the input here on our schematics, and it's going to go, and it's going into the tin box. And we're going to, it's got a red load resistor just to have some load. So we're going to put the negative on the negative and the positive on the positive. I'm going to put that cable in here, and we are going to close the box and also put that ground, so we can ground the tin box. And it's now grounded. And so now we're back here on our software, and as you can see on 1 kilohertz here, you could see a big spike and goes up to just past the 1 volt by a little bit. So it's not exactly 1 volt. It's actually showing here to be about 1.7 volts. And we know that's not 1.7 volts, that is 1 volt. So how do we tell the software that this is 1 volt? So what we're going to do, we're going to say calibrate level. We're going to say 1 volt here and just say calibrate. And just say OK. And automatically you could see the line goes exactly to 1 volt. So now we know this is calibrated. So if we are measuring things, we know these are going to be accurate measurements within reason, that are not just inflated by the volume control or anything. But once you get this set up, do not change anything on your volume control of the sound card or anything like that. Just keep everything the same, because it's critical, because it's being calibrated. Otherwise, if you do change things, you have to recalibrate again. So now you know all what you need to measure ripple to a very low 1 microvolt level using just equipment that you probably have lying in your house or very little amount of money. To make the video short, I'm going to do the examples of measuring different power supplies on a separate video. I'll put a link of it in the corner, and if you don't see it, give it a few days and I should have it ready. Please subscribe if you haven't, like the video if you like it, and I hope to see you again because we're going to keep on going on this Ripple mission for a little while, and I hope to see you next time. Take care.